video is on scatter graphs, and I'm going to draw a quick sketch of what a scatter graph looks like. And as you can see, it's quite self-explanatory. It's hard to forget because these look like little random scatters on a graph. Now, there are different things they can ask you with a scatter graph. So the first thing they could ask you about is a line of best fit. And this is where they'll give you a graph with its like little points on, and it might tell you to draw a line of best fit. And that is quite self-explanatory. You draw a line through the points that fits it the best, basically. So for this example, you'd get your ruler and you'd go through here. But we can see there's kind of a funny point here which doesn't really fit the general trend. And this one here is called an outlier, because it's kind of not really lying where we want it to lie. And that might be someone's inputted data incorrectly, or they're just a bit abnormal, whatever it might be, there'll probably be a reason. And you ignore that when doing your line of best fit, because otherwise it would really skew your line and it make your line less accurate. So you might go about, something like that might be a line of best fit. The second type of thing it might ask you about is correlation. So correlation can be positive, negative, or just non-existent. So I'll draw an example of these. So here in this diagram we have an example of positive correlation because it's going upwards. So as one gets bigger, the other value gets bigger. So as here we can see we have positive correlation in this example because as the temperature goes up, the number of burnt people goes up. In the green one, so the line of best fit is going this way, the green one, it goes this way, so that means we have negative correlation. So as you can see, as one goes up, the other one is going down, so it's kind of the opposite relation. And then this one here, we have no correlation because they're just kind of randomly placed. There's no real trend going on there, so that's no correlation. There are also ways you can describe it. You can have strong or weak. So you can have strong or weak correlation, meaning is that correlation kind of really strong or a bit weak but still there. So for example in this one you can see these are really close together. It's really kind of obviously straight up. We might say is a strong positive correlation, whereas this one is slightly weaker. They're less sort of on the line of best fit. So you might say that has a weak negative correlation, and then no correlation just has no correlation. So the next thing it could ask you about is estimate a point. So it might give you this scatter graph, and then it might give you a line of best fit, or you have to draw a line of best fit. And then you use that line to estimate values. So for example, if I didn't know what this was here, I could estimate it. So let's say whatever temperature that is, I want to know how many burnt people there are. I can estimate the number of burnt people by going up to the line of best fit and across. So that's not actually a data point that we collected. However, we can estimate it, so we don't know for sure. It's an estimate using our line of best fit. One thing to be really cautious of is where our data points stop, so up here for example, you can't actually be sure that that's how the line of best fit would go. So if you're estimating values up here, they might actually be unreliable because you didn't actually get any data up there, so you're just kind of extending the line without actually having any proof. So in places where the line of best fit, you've just extended it but there are no data points, it might actually be an unreliable estimate, but the estimates where you have your line of best fit are normally pretty good estimates. And then the final thing they could make you do, which would probably come at the start, is they'd give you the data and they'd make you plot the points. So that's just like plotting XY coordinates on a graph. So you'd have to plot these scatter points on your graph. One important note to make is that correlation isn't causation. So this statement, correlation isn't causation, basically means the correlation, so the pattern, so if you have one thing increasing, another thing increasing, so let's say I have a positive correlation, isn't causation. It doesn't mean that one causes the other. So in this example, we have the temperature increases and the number of burnt people go up. That does seem like the correlation kind of is causation, because as a high temperature, more people are likely to burn. But there are examples where this isn't the case. So basically, it could be a third factor is actually contributing to both of them, which increases them both, not each other. So one example I was once told is that the amount of people who drank, the more coffee you drank, increased your chances of cancer. So what it would look like on a scatter graph like this is the amount of coffee you drink and your likelihood to get cancer, and they would go up in a positive correlation. The more coffee you drink, the more likely you are to get cancer. But turns out it wasn't actually each other having an effect. It wasn't coffee making you more likely to have cancer. It was actually a third factor, which was smokers. So people who drank more coffee were more likely to be smokers, and that's actually what was increasing their risk of cancer, not the coffee consumption. So from looking at a scatter graph, it looked like it had a really good positive correlation, and it looked like you'd be like, oh, just drinking more coffee increase your risk of cancer, but really it was the fact that more smokers drink more coffee, and it was actually the smoking that was increasing the risk of cancer, not the coffee. So it's important to think, just because it looks like that doesn't necessarily mean that's what the data is saying. So now we're going to look at 2 exam questions for practice. So here is exam question number 1, and it shows that the scatter graph shows the maths mark and the art mark for 15 students. So it's showing that as your maths mark goes up, your art mark seems to go down. So what type of correlation does this scatter graph show? So it's either positive, negative or no correlation, and it looks like the trend is going that way. So as one goes up, this one goes down, so it's going to be negative. Then part B says draw a line of best fit on the scatter graph. So we have to try and get the best looking line to fit these data points. So I've gone for something like that. I'm not gonna lie, I find drawing a line of best fit really stressful because there's no actual like exact right answer. It's kind of within a region, and I like to know my exact answer is correct. So yeah, that's my line of best fit. Then part C says, Sarah has got a maths mark, her art mark is 23. Use your line of best fit to estimate a maths mark for Sarah. So this is estimating point using your line of best fit. So we've been told that her art mark is 23. So this is her art mark. So let's go up to 23. So we've got 20 and then 1, 2, 3. So if we go along that line there to meet our line of best fit. Now we want to estimate the maths marks, then let's drop down and see what maths score that would give her. And that looks a lot like 30, 1, 2, 3, 4, 5, 6, 7, 37. So that is how you would estimate using your line of best fit. So that's estimating point. There was no data point that actually said that someone had got 23 in art and then they got 37 in maths. We're just using the line, and that would be like quite a good guess, basically. So let's try another one, see how similar they are. Okay, so this exam question, the scatter graph shows some information about 8 cars. For each car, it shows the engine size in litres and the distance in kilometres. The car travels on 1 litre of petrol. So basically it's like saying how far a car has got on their litre of petrol with different engine sizes. So part A, what type of correlation does this scatter graph show? So as you can see, that was the exact question we were asked on the previous question. So as we can see, it's going this way, so it looks like negative. Because as one goes up, as the engine size goes up, the distance it seemed to travel went down. Next part says, a different car of the same type has engine size 2.5 litres. Estimate the distance travelled on 1 litre of petrol by this car. So this is interesting because it's exactly the same as the last question before, but our previous question gave us a middle step of drawing a line of best fit. So when we have to estimate values that aren't actual data points, we have to draw a line of best fit. So that's the first thing you're going to have to do. So then estimate. That is going to be my line of best fit, and it's saying that a car has engine size of 2.5 litres. What distance has it travelled? we know it has an engine size of 2.5 litres, so we go to 2.5. Then we're going to see what our line of best fit is saying for that. Okay, now we're going to go across and see what distance we get. So that distance looks like, so this is 10 and that's 12 and it's halfway, so that looks like it's 11 and it's given us the units kilometres. So again, that's an estimate because we weren't given that value, no one actually tested that, but we've used our line of best fit to find it. And that's all you need to know and all they can ask you for a scatter graph.